In this problem, we have an object that weighs 9 kilograms. It's dropped from rest and it starts falling through a viscous fluid. And we know that the viscous fluid is such that the drag force is given by minus B times B. And we're also told that it takes the object 5.54 seconds to reach half of its terminal velocity. Now, since we're falling through a viscous fluid, we know that the velocity of the object as a function of time is given by this, where this is the terminal velocity, and it's 1 minus the exponential of minus pt over m. M is math, and b is just the drag constant of the fluid. So first we're asked to find, okay, what is the terminal velocity? In order to find the terminal velocity, first we need to find the constant b. So for that, we use the fact, okay, we know how long it takes to reach half of the terminal velocity. So we just replace that in our b as a function of time. So we evaluate b at 5.54 seconds has to be equal to 0.5. 0.5 dt. Then dvt go away on both sides. And we find that this is equivalent to saying this relation. And right here we can solve for b. So b is just equal n log 2 over 5.54 seconds. Then the terminal velocity is found by this equation. We know from this relation that this is what the terminal velocity has to be. And it's just a matter of replacing our expression for b. So we get g, the gravitational constant, 9.8 meters per second squared at 5.54 seconds divided by log of 2. That gives us 78.3 meters per second. So next we want to know, okay, how long does it take the object to reach 3/4 of its terminal velocity? So again, that just boils down to equating this b of t to 0.75 times pt, which in the end is equivalent to saying, 1 minus this exponential evaluated at this time t1, which is what we want to find, is 0.75. That's equivalent to saying that the exponential of bt1 over m is equal to 4. Over here we can just take a logarithm on both sides to find t1, which tells that the time it takes to reach the quarters of the terminal velocity is just 11.1 seconds. And finally, we're asked about the distance traveled by the object. So what is the distance traveled by the object as a function of time? Is we're going to take this function of v of time and integrate it. So we're going to do the integral from 0 to t of b of t. It's equal to integrating this. And if we do this integral, out comes this result. So we have terminal velocity times t, n over v times the terminal velocity, 1 minus this exponential. Now, these are all known quantities. We have calculated pt, we know v, we know m. So it's just a matter of plugging in the numbers and evaluating y of t at t equals 5.54 seconds. And if you do that, you'll find that the object falls down 121 meters.